Fire in the hole. Welcome back to Fro-Dog Arcade Repair. All right, what we have here is chassis number 8 in the Sanwa series of 7. Imagine that. So I was looking around on eBay, and this was listed as and sold as a Nanao, N-A-N-A-O, 27-inch chassis. I took one look at it, and I'm like, well, that's exactly like the Sanwas that I'm fixing. So I dug a little bit into it, and this is, if we look right here, we see the model number. I'll have to bring that up so everybody can see it. It's a PM1745B as in Baker, where we've been doing C's as in Charlie. Substrate of the board is green and not tan. Some of the components look a little different, like that looks a little more like a wire wound resistor, but the layout and the pieces parts all look right. Now this one did not come with a remote board. Since I have other units, I've got a remote board I'll be able to test it all with. But I saw it on eBay, and I'm like, well, I just can't resist. I got to get it too and see what we can do. Now, this was sold as is, unknown, untested, 4 parts. And somebody been with a Sharpie and had a lot of notes on the side here, 4 parts. C3831. I don't believe that is the same part number as what I put in that other 1745C, but I feel reasonably confident it will be correct with the transistor I put in the other one if that one turns out to be bad. See right here, we got 27-inch, okay, bad connector control PCB. Bad connector control PCB. Maybe it had a bad remote board, and that's what that note means, or we'll check the header pins and connectors for where the remote goes. What do we have here? HV, high voltage, all parts okay. We got a date code from the manufacturer, 0103. Got more notes over here. We got D1887, which is what is in there. I don't believe that was the same number as before either. Again, neck board looks the same except green substrate. The layout all looks the same. We've got wire wound 3.9Ks instead of like the metal oxide ones. Looks like, I don't know if that's original or not, but it almost looks like a piece of cardboard is here for the vertical IC over here. We'll dig into that a little bit. But overall, appears to be in pretty good shape. This kind of filthy. We do have a pot that's bent over here. Let's see if we can slowly and carefully bend that little boy back up straight. Not bad. I don't see anything visibly cooked, busted, broken, missing, anything like that. No, I think what I'm going to do is I'm going to start by taking this metal frame off, and I'm going to give it a wash and a dry so we have something clean and reasonable to work with, and we will go from there. But I'm going to call this one Sanwa number 8, or if it's truly a Nanao, a Sananaowa. Yeah, making huh? Might have to bleep that one out. Anyhow, I don't see anything that screams terribly wrong or anything, and it's seen a few more hours. The board's got, a little bit of discoloration on the bottom where it's been hot. So we can see here, we've got a little bit of heat discoloration through here. We have a couple heavier resistors. I don't know. The flyback may or may not have been out. There's been some reflow and touch up on this board. that flyback work could just be reflow. I do notice that we don't have our little resistor on the bottom side here. Let's see, where are we at? On our Sanwas, we've got a little external resistor they've put across up here, and I don't see that on this chassis. I do see these two diodes added. They're not the same diode, but they're a diode. Got a couple little bulbous, chunky things. I definitely think this transistor from the power supply has been out. It does not appear to be soldered well and or making good connection. So that could be an issue. But overall, I think we're going to start with a bath and then come back and poke around with a meter and see what all we might have going on. Okay, we're back after a quick trip to the wash tub. I have not dried this on the overnight with the fans. This is just freshly washed and blown off with the air chuck. Way better visibility into the components. Way less grunge to deal with. I think we kept most of our stickers intact. We did have this one right here that disintegrated on us a little bit. But no, I think overall looks pretty good. We clean up the bottom of the board ultimately with alcohol and a toothbrush. We'll get, yeah, I think this white haze will go away. This board was a little dirtier. The dirt seemed to have almost a grease quality to it. I had to use a little bit of Dawn in there to really get it to scrub clean, especially on the CRT board and socket. But even though it's not dry enough that I'd light it off, it's dry enough to poke around with a meter. Let's see what we got. Let's go to continuity first and take a look at our fuses. Now I do notice these are glass rather than ceramic on this one. I'll probably put ceramics in it. Main fuse is good. Power supply fuse is good. Do they check just as good out of circuit? Ooh, there we go. That's a tough one. That one's good out of circuit. And make sure it's not touching. That one's good out of circuit. So that's a good sign. Now let's go over to diode check and take a look at this transistor in the power supply. Seems to test okay. I don't think the solder on it's quite the best. We'll have to touch that up. Let's look at the HOT. What do we got going on over here? I think one of the early things I want to do is get this CRT board off so we can manipulate this a little better. Because we'll ultimately start with a bench test, see if the power supply lights up like it should before we get over to hooking it up to a tube. Let's see, the iron's hot, so let's get our G2 wire off here. And let's open up for our line into our CRT socket. There we go. Okay, there's that. And our CRT board is off and out of the way. All right. Oh, now there's something different. Where our others had just the low and not a high connector, I'm thinking this is potentially a dual resolution chassis. It's sitting on the high res, and we've got a low res connector there. So we'll take a closer look at that as we get deeper. But let's see, does our HOT have any dead shorts? Nope, nothing to the case. There's one junction. The two outside pins read short on the other ones when they're in circuit. But let's see. So that'd be base to emitter. I don't think the HOT is shorted. We'll, I think if it were, we'd see a blown fuse. I don't know. I think it's possible that this old girl just light up. I don't see anything funky going on with the flyback. Really, this looks like a virgin board. I don't see any real component replacements. Like I said, I saw a little bit of reflow on the bottom. Let's check our 3.9 ohm resistors here. 4, that's reasonable. Yeah, I would expect one of those to be open if we had a horizontal circuit problem as well. Or I should say a high voltage circuit problem with the HOT shorted or something. What about just some of our sand blocks here? Or not sand blocks, but metal oxide, heavier power resistors. Now our sand block, yep. That's interesting. I think that one should be like 5 something K. Yeah, there it is on the side. I can see it now. Bring it back into frame here. This should be a 5.6 K, and we're not getting any reading on the meter. So could that be open? All right, I say we pull this resistor right here and see what it reads out of circuit. I think we're going to find it's open. Usually a big Chemwick fan. Chemwick's so expensive, I decided to try some generic braid and see how it worked out. Towatt, made in China. It's actually not bad. Seems to work pretty decent. It's not Chemwick, but you know, kind of like, it doesn't have to be a Porsche to get you to work. It still gets you to work. Let's see. Now that's interesting. We got the 5.6K out of circuit. Are the legs just tarnished and I couldn't get a good read on that? They are kind of tarnished up. I'm going to go with that as a strong possibility. I'm going to burnish them up just a little bit here with the fiberglass pen. That way we'll be able to make sure we get some good solder wet into them again. All right, I think the camera was off for a little bit while I was poking and checking around there. I'll have to go back and look in editing and see where we're at, but I'm going to give a quick recap of what we've done so far. Checked with a meter some basic components. We pulled this 5.6 out, 5.6K resistor out because I wasn't getting a reading on it. I think it's just corroded legs. It tests good. Our transistor in our power supply looked good. Our HOT looked good. I did figure out or find that this has the high and low connectors both populated, and it's plugged into high. So I think this is dual resolution chassis version. On the bottom side, we resoldered our power supply transistor that was a little sketchy. We looked at Q403 that has been problematic on others. And in general, there's been some reflow. It's a little goobery, but not bad. As I was talking, I'm kind of a soldering snob, so just because I don't necessarily like the looks of it doesn't mean it's not a functional connection. So looking at everything on the underside of the board here, I touched up just a couple things like the power transistor. I didn't do anything with these header pins. They all looked good. For the most part, everything looks tight, functional. I don't see any ringed connections. Nothing cracked. No breaks in the board. Everything looks good. So on the top side, I said I checked the HOT, power supply transistor, hit some of these heavier power resistors, these oxide resistors, and I just pulled the B plus cap out to put it on the capacitance checker. Let's see, 680 microfarad at 200 volt, and we're reading 506. So 10% is 68. 68 and 68 is let's see. 68 and 68 is 120, 136. 136 down from 680. 585. This is out of spec. 20% would make it in spec, but it does have a nice low ESR of only 0.1 ohm. I'm going to consider replacement on that. It's outside the 20 range. So we'll look at that as a replacement item. Also took a look at, looks like there have been a couple of caps replaced, 3 of them in the power supply. These 200 mics and this little guy right here, I forget his value. The glue has been broke. I pulled one of them out. It's a KMF branded capacitor, though it is dressed and looks like a Nichicon. So I think there might be a little bit of... how do you say it looked like a Ferrari, but it's not a Ferrari. Well, Cat Williams, that was it. He said, if you drive a Chrysler 300, just say you drive a Chrysler 300. Be proud of it. Don't be saying it looked like a Phantom. It only looked like a Phantom till a Phantom roll up. They only look like Nichicon till you get them out and put a Nichicon next to them. But anyhow, I digress. So we're going to put a new B plus capacitor in there. We're not going to get crazy on the rest. I just want to get it lit off. So I'm going to get a B plus capacitor in there, get it in front of the fans, let it dry good 24 hours or more, and then I think we're going to try to light it off, see what happens. We'll do it statically on the bench here first, just to see the power supply section come up. And we'll go from there. Okay, welcome back. we have on the bench before us here Sanwa number 8. I got to digging a little deeper. The seller on eBay called it a Naneo. Nowhere can I find marked on the board anywhere else Naneo. It is clearly marked over here as a PM1745B as in Baker. I believe it to be a Sanwa with no Naneo connections. So Sananeo is not going to be applicable. But anyhow, I checked over the board, went through, both fuses were good, but I went and updated this one to the ceramic instead of glass like our other Sanwas. I checked our high points like our power supply transistor, our HOT. I checked our oxide resistors that are fusibles coming into various power sections. It does not look like it's had a cap kit. It overall, after I washed the board, it looks really pretty clean and decent. Flyback looks original. But from what we learned on how to adjust B plus and our other Sanwas, I believe I can light bulb test this by pulling our 1.6 amp fuse here. I've got on the power supply side connected my gator clip over to my meter lead and our test point over to my meter lead, as well as our light bulb in parallel across. So we should be able to power this on power supply section only without lighting up the horizontal side, because we've got that 1.6 fuse out, and see if our power supply works. I cannot find a reason that says this should not light up. Since we are not 1000% sure on our chassis, I do have the anode, the high voltage anode, down in a glass cup, kind of off to the side there since our picture's taken up everything. But here we go. We're going to light bulb test it and see if our power supply is working. Fire in the hole. I would say she's working. 92.1, spec is 96. So I'd say we're pretty close there. The silicon has never been taken off of the power supply pot. So I would say that has not been adjusted. And ultimately we would adjust it after we did a cap kit and did a full burn-in. But seeing that the power supply section lights up, that I see nothing broken or wrong looking over around the flyback, no burnt traces or anything, I'm thinking this might be one of those eBay units instead of somebody's problem child dog that they couldn't fix and threw in a box off to the side, that maybe this just came out of a monitor and got thrown in a box on the side. So this is our unknown, untested unit from eBay, and so far so good. It seems to be unmolested, complete, and or at least our power supply is working. So let's take it over to tube and fire in the hole again over there, see what happens. All right, we have Sanwa number 8 over here on a tube yoke and chassis. We've got our degauss hooked up. We've got our neck board on. We've got our DAG ground. We've got our high voltage anode. We've got our power back there, our signal cable over here, our remote board, which we borrowed from one of the other Sanwas. This one did not have a remote board. We've got our power and our test pattern generator. Now, I know I swap around test pattern generators a good little bit. I've got my trusty old school BK 15 hertz CGA unit there. That's just good old NTSC color bars, some raster, some grid. I use that more for burn-in, and I've kind of gotten lazy when I've been adjusting up some of these Sanwas as far as I've proved out it works with that, but if I'm really going to tune one on the tube that it belongs on, it's the Crafty Mech. That's the unit that you really want to tune and use if you're getting it down closer to the gnat's ass on how you want your colors to look. It's got more patterns, more just general usability. But the old BK does good to get you in the ballpark, let you know that it's working, and doesn't need a battery if you're going to let it burn for a long time. Now, I've got this on standard res. We do have this B chassis. Get my picture down here. Has the high-low plugs for resolution. So this is a dual res chassis. I put it on low, which is the same plug we've been using on our other Sanwa 1745s. So we're going to start this out at low resolution, see what happens. But everything's hooked up. We tested power supply on the bench. We're going to find out if the rest of the chassis works, for high voltage works. So no time like the present. Fire in the hole. Okay. Heard it come up. Maybe not the best picture, but it's got a picture. Let's find a tool over here. Let's see if I can be a better cameraman than I have in the past. See if some of our pincushion will adjust a little bit on us here. That would be a negatory Ghost Rider. What about some of our others? How about vertical size? That's working. Vertical hold works. Vertical position works. Horizontal position, because the pincussion's where it starts its fold over there. Let's look at horizontal hold. Horizontal size doesn't work. Alright, I have Sanwa number 8 back on the bench, and I thought I'd share this with you because I've never seen this before. I went to that R435 where I found the lifted pad that I had a suspect that it could have been related to my pincushion not functioning problem. But on this one, I go to it and I wondered why it had this funky footprint of pins when on the other Sanwas, there we go, we were just connecting here and here with a 5-watt sandblock resistor stood on its end and the two legs routed down in the hole. Well, first off, I don't know that that's going to be related to pincushion because there's no pad problems, no connection problems, and the resistor itself is not open. But the interesting thing is, I've never seen a resistor like this. Check out this little can. 10 ohm, 5 watt. And it's a little metal can. I just found that so fascinating. But that explains the funky pad layout on the board, that it was designed that it could use this type of resistor. What I ended up finding was on this transistor right here. Q406 had a pad on the circuit board that was broken away from the trace and not making connections. So we had a bad connection that I fixed on the circuit board, and that brought our pincushion back. Now, I have seen some other folks on forums talk about that Q406 being bad and creating pincushion problems. So that transistor could indeed be bad and cause pincushion, or you can have bad connections around it. Being that it is a little bit larger, got it strapped to a heat sink, does create some heat and can indeed mess with your solder connections. Now overall, we've got our light bulb and our setup over here to adjust B+. We've got a stable 96.1 volts for 96 volt B+ adjustment. We're running our Crafty Mech test pattern generator. We got it to color bars. Let's cycle through some stuff here. Still got that little bit of purity down in the left, but I'm going to degauss that before, or once it's back in the cabinet and at its final destination. I find that these YS tubes that the Sanwa series come on are not necessarily the best or highest quality tubes. I do see a little bit of convergence and linearity that you just can't seem to adjust out of them, but it is well within the realm of acceptable. Overall, I don't know if you can hear it on the recording. There is a little bit of a high-pitched noise. The chassis in general talks just a little bit. I can't push on it, can't flex it in any way to make that little bit of chatter stop, change, or otherwise, so it's not a connection problem. It's not flyback loose. I think it's just the nature of this beast. It's very, very minor. I think once it were in a cabinet and not out an open exposed air chassis like this, you'd never hear it, never know the difference. Some chassis just talk a little bit, has been my experience. Just like you can't get perfect linearity, convergence, pincushion on various tubes, and some are better than others, and you strive for the best you can and work in a capacity of livable. But this is again Sanwa number 8, fixed, done, dusted. Got our capacitor kit in, a reflow done, and it's been just burning away here on the chassis. I'm going to let it go overnight, and we're going to call that one good. So all 8 Sanwas fixed and complete. Thank you for joining me at Fro-Dog Arcade Repair. I hope you enjoyed the video, found it useful, or at least entertaining. Please subscribe below, like, follow, and share with your friends. And remember, fire in the hole.